You're excited, so you dive right into code, you start working on it, work all-nighters for a couple nights, just you're so excited that you get something done. You add on a dash of front-end niceties, and you have something that's ready to release. You've reached MVP, your minimum viable product, and you ship it out. You set up a store, you do some marketing, pretty soon people are actually paying you real money for it. You're seeing sales, you're a success. Everything went exactly as you planned. So, what happens after that? Well, it's in the hands of users now. They start talking back to you. They give you feedback. They start telling you, when I do X, something weird happens, or I wish your plugin could also do Y. And so, your users start helping to drive the path of your development. And you figure out what features you need to work on, what bugs you need to fix. So, you have some work to do. You get back to work, but at this point you actually have users paying for your time, so you're pretty excited to be working on this still. So you start patching bugs, you start adding features, you write some user documentation so everybody has a better experience overall. You release version 1.1 and everybody's rejoicing that it's getting better. And so what happens next? You do it all again. You get more feedback. Users starting to tell you that they have more bugs, they want more features. And yeah, this thing that used to work, it's broken now. And thanks for adding this feature. Can you add more features and more features? And so you go back to work. You start patching more bugs. You start adding more features. And your code base is growing larger and larger, more complicated. You start hiring another developer to help you with all of the extra load. You hire support people to help you with all of the incoming requests. And so people you're working with start adding new features to your plugin, but those are breaking features that you wrote. So you fix your features, and your bug fixes are breaking your other developers' bug fixes. And you spend more and more time, every time you make a change, just cleaning up the debris from the explosion of bugs that you have every time you make a change. And so eventually you just stop building new features so that you can take some time and go in and clean up this mess. And your plugin isn't progressing anymore. You're getting tired, frustrated, exhausted, burnt out. At this point, you're drowning in technical debt. What is technical debt? It's basically the consequences of all of the choices you've made along the way. The work that you don't have done yet. It's basically anything that's standing in the way of your work being done right. Chris Lemma likes to give us the word done. That yeah, it's working, but there's still more polish to do to it. Martin Feller tells us that it's a debt that you incur every time you avoid doing the right thing, like refactoring, removing duplication or redundancy. It's letting your code quality deteriorate over time. So where does this technical debt come from? It can come from rushing through coding. You don't take the time to consider the design, software architecture. It's not that you don't know how to write code, it's that you're already coding before you know what you are coding. You haven't taken the time to actually think through everything, flesh out the problem domain, and figure out a good architecture that's going to fit with that. And even if you started out with the best intentions and laid out a good design, as you're working, you're going to gain a more thorough understanding of what you're doing. And so, as you get into all the nooks and crannies, you start realizing that your overall model isn't quite right. If you don't take the time right then to refactor things to make it match, then you're inheriting debt, or you're incurring debt. Let's say that you skipped over automated testing. You think, I have just a small plugin. There's no reason to do automated testing for such a small thing, or this is complicated. It would be hard to test, and it's too much time to spend on it. Well, you don't have those tests, and that's going to come back to haunt you in the future. You get debt by leaving unused code in your code base. So let's say you have a function that you used to use, but now it's not being called. You come back later and you look and think, why is this here? Is it doing something? Is it doing it right? Should I be calling this function? Or you have stuff that's commented out. It's just distracting you every time that you're trying to write code. You get technical debt every time you leave one of those in your code, a to-do. Basically, you put those in saying, I'm going to come back and work on this later. I have something I know needs to be done here. I'll do it later. Later means never. So make sure that if you start writing one of those in your code, you actually need to do it instead of just saying you'll do it later. Even worse than writing it to do in your code, though, is not writing it to do when you know you need to do something. Because then you have a problem that you know you need to fix, and you're going to forget about it, so it's even less likely to forget about it. You get technical debt from failing to write documentation, not just user documentation, but developer documentation. That includes things like inline comments, saying, why is this code here? What is it doing? How is it interacting with other code? And using descriptive naming on your functions, your variables, your classes, and having diagrams to let you know how all of the pieces are relating to each other. The common thread to all of these is that you haven't taken the time that you need now to do it right. And so you're going to spend that time and more later making up for it. So what are the consequences of technical debt? Your code breaks unexpectedly. When you bring new developers onto your team, it's harder for them to understand what's going on. Every change you make ends up with a higher cost than you were expecting because of this effects, the snowball effects, where you're making a change here and it causes other problems over there. You end up fixing the same bug multiple times. You get frustrated as a developer. Your users, your customers are frustrated because they're not getting quality products. They're not getting them at the time they expect them. Everything that you're doing just ends up with greater risk. Gordon Cunningham tells us that every minute that you're spending on writing or on dealing with, let me just read it. Every minute you spend on not quite right code counts as interest on your debts. That basically you're losing time in the future because you've made these choices in the past and you have to pay interest payments on it. So what do you do about it? Obviously the right answer is not to take on the debt in the first place. But sometimes you have to, sometimes you're inheriting code, sometimes things happen. So let's say you have the debt now. What are you going to do about it? Well, there's really two options, the exact same two options that you have with a financial debt. You either declare bankruptcy or you pay down your principal. Declaring bankruptcy is rather appealing. You just throw everything away and a phoenix that looks like a penguin rises out of the ashes. And it's going to be glorious. You're going to do it right this time. You're going to have a better understanding of what you're working on from the get-go. You know that you'll have a better architecture, and you're not going to have the time pressures because you already shipped something and you're making money, and so you can take the time to do it right, you think. But it really doesn't ever work out that way. And you're going to make the same mistakes again and again and again because either the reasons you didn't take the time in the first place, they're still probably going to be your reasons today, that you're still going to have time pressures that you weren't expecting. You're still going to not have a complete understanding. And so, even though you're building again with a better understanding, there's still more to do. And while you're doing this, your product is stagnating. Or if you're working on a customer's website, that's stagnating. And they really don't want to pay you to write their entire site again. And once you're done with it, you're going to have exciting new bugs and features to play with. So if bankruptcy isn't the right answer, what is? It's paying down your debts, getting out of debt and paying down your principal. So financial counselors will give you advice on different ways to go about getting out of debt. One of the techniques they recommend is the debt snowball. For those of you in Orlando who've never seen one, this is what a snowball looks like. The debt snowball is a technique for paying down your debt that has been, in studies, shown to be actually more effective than other methods of paying down your debts. If you follow this technique, you're actually more likely to follow through, go through the necessary steps to get out of debt and stay out of debt. How it works is you take your debts, you order them from smallest to largest. You don't worry about interest rates, you just worry about how much do you owe. If you have a $10 debt with a 2% interest rate and a $100,000 debt with a 6% interest rate, you still pay the $10 debt first, even though you're hardly incurring any interest. And while you're still making the minimum payments on everything, because you have to keep paying all your minimum payments or you're going to be going to court, you're going to be declared bankruptcy. you try to find a little bit of extra capacity to pay off your smallest debts. And after you've paid off your smallest debt, you take everything you were paying into that one and apply it to the next smallest debt. And so you're making bigger payments on that one. And once that one's done, you take all the payments you were making on that one and apply it to the next larger debt. Until eventually, everything that you were paying over a wide number of debts is all being applied towards your one remaining debt, which gets paid off more quickly. It's not mathematically the best way to pay off debts. You're going to end up paying a little bit more interest in the long run, but it works psychologically because you have clear, achievable milestones. You can see the progress you're making. I've got this one done now, and now I can go to another one, and it's done, and I can go to another one, and it's done. And every time you get one done, you see yourself moving faster on the next one. So while it's not mathematically the best choice to make to pay off debt, it's the choice that actually gets done, the choice that you can follow through. So how does this work with code? It's certainly not quite as easy to itemize your debt that way with code. But there's still clearly some things that you can see in your code that will make it so you can follow a similar method. So the first thing to do is just assess what debts you have. A first obvious one is, do you have automated tests for everything? If you don't, you need them. Do you have comments telling you why the code that you wrote is written the way it's written? Do you have a consistent code style? Are you actually using the right overall framework for your code? Is the design, the architecture of your code correct? There's small things there, there's big things there. And you can probably break all of the big things down into smaller chunks too. And try to apply some time estimates to them to see how much time it will take to get things done. And then once you've actually made a list, it's not going to be a complete list, but it's a list you can get started with. You can set aside just a little bit of time to start paying off those debts. Let's say you can only dedicate a half hour to an hour a week towards paying off your debts. That's a lot more than no time. And you can use that to begin making small payments on your debts. You address one issue at a time, you get it done, and then you take your time the next week to get something else done. As you keep doing this, your code's going to get cleaner, you're going to have better test coverage for your code, bigger changes that you make will become easier because you've made the smaller changes in the past. And so the little bit of work that you've done up front starts to snowball into bigger and bigger changes. It's going to make your code better, it's going to make your life easier, it's going to make your customers happier. And so you don't need a huge initial investment to go and rewrite everything. You just have to start now and do something, and over time, wait for the results to come in. It takes time and discipline. You don't get a quick fix. You have to have the discipline to keep paying off your debt. Do a little bit every week, or every month, whatever time frame you decide to work with. Just keep sticking with it. And the other discipline you need is to stop incurring new debt. So when you're writing new code, when you're adding new features, you actually need to be testing things. You need to do the refactoring you need to when you need to do it. So while you're paying off your old debt, don't get deeper into debt. So where do you get started? I highly, highly, highly recommend starting with automated tests. It's really the foundation that makes everything else possible. And I don't mean setting up 100% code coverage where everything that you've done is tested. Just test something. One little test. Most of your code is probably right now detestable, meaning that you can't actually go in and test it. You have huge functions that you can't isolate pieces of them and test them. So what I'm going to recommend is, instead of starting at a unit testing level, start very broad with acceptance testing, UI testing, or black box testing. There's lots of words for it. But some tools that you can use to do that. PHP unit is basically the foundation level for testing. It's the system that runs all of your tests. It's what WordPress uses for its testing suite. A lot of other plugins use it. On top of PHP unit, there's a tool called Codeception, which is basically for browser-based acceptance testing. So it can use an actual web browser, or it can simulate a web browser. And so instead of testing, is this function doing what it's supposed to do? You're testing, when I click this button, does that cause the right results? So you don't have to worry quite as much about having isolated testable pieces of code. You actually just automate the process of testing it like a user would be using it. On top of these two pieces, a library recently written by Luca Tumide called WP Browser. This is a codeception module, so it works right on top of these other two pieces. So it's a stack of 3 pieces you'll need that basically makes codeception play nicely with WordPress. So you can include this inside your WordPress plugins to make it so you can start writing tests. Just to show you examples of what it takes to set up a test like this, in your project you set up a composer.json file that tells it basically that you want to require codeception and WP Browser, those 2 libraries, and it will automatically pull in PHP unit because that's a dependency for both of the other 2. So this is basically just a configuration file you run a composer with. If you don't know what composer is, make sure you learn about that. That's the first step you need to pay off. You set up a configuration file for codeception, and specifically this is for the WP Browser portion of it. All of these things should look familiar to you. They're your usernames, passwords, URLs for WordPress. And so you're just pointing it at a valid WordPress install. The one specific piece to point out is this line here, dump. That's an actual dump of your WordPress database. So that every time it runs a test, it's going to overwrite your database with that to give it a clean slate to start with for each test. So you don't necessarily want to do this on your production site because it will overwrite to everything that's there. So you have to do this in your local environment. And then you just tell it for this specific group of tests, you're going to use WP Browser. WPDB is a tool for looking into the WordPress database and looking for information there. And UI Helper is one that's automatically going to come with codeception. And then you can write a test. This is probably the most basic test you could write. It's pretty easy to read. You're just saying that I'm going to log into WordPress as an administrator. I'm going to go to my plugins page, click the button to activate my plugin, and then back on the plugins page, see that it's active. You've right there established that turning on your plugin doesn't crash WordPress, you don't get a fatal error, that you can go and activate it and then still load the admin after you've done so. It's not a lot, certainly, but it's a start. And once you have this start in place, you can start writing new tests very easily because you already have the framework in place. But the codeception tests are very easy to write. You're basically just going through the process of clicking links, clicking buttons, and making sure that the results are what you expect. So even people that aren't really well-trained developers, they can still write these tests. So if you have a QA team which just knows a little bit of PHP, they can still write your tests for you while your developers are writing new features. Or if they find bugs, they can write tests that show you exactly how they reproduce that bug, instead of relying on descriptions that probably aren't quite accurate. So on your command line, you run codecept run, and it will tell you OK, and you're ready to move on. The next thing you can do after you've started writing some tests is write some documentation. Do you know how your own code works, or are there pieces of it you're unsure about? So start writing comments on your functions so that you know why they're there. And you don't want to write comments saying, this assigns 7 to X. You could read the code and see that. You want to have comments like, we wrote this to override what's happening in this other plugin so that we get the results we're expecting. Basically, comments that tell you why it was written that way, how it relates to the other pieces of your code. You can start drawing diagrams so that you know what's going on. You can see when a user clicks this function is going to call that class and get this response, and then it's going to call this other class to do this other thing. So look into UML class diagrams and sequence diagrams to really help you understand how all your pieces are related. This isn't the time to make all of your code make sense. It's the time to understand what you actually have to start with. Document all of the relationships and dependencies among your various pieces of code. Put C references in your doc blocks. And especially when you're putting in C references, put it on both sides. So put it here to say that when I make a change here, it's going to cause problems over there. And over there, say when I make a change here, it's going to cause problems over here. So that when you're in there making those changes, you actually can see that and remember it and not end up having unexpected changes happen. Now, after documentation, you can start writing some style guides. So how should you be naming your classes, your methods, your files, so that you can have a consistent way of naming things so you can find things later, that you're not going to spend 10 minutes looking through your code and doing Control F to find what is this thing that I vaguely remember. Be consistent so that you can predictably find things. Document how you're going to use tabs or spaces, brackets. I recommend if you're writing WordPress code, follow the WordPress standards. And consider what PHP versions and WordPress versions you're going to support. Are you going to support PHP 5.2 and WordPress back to 2.5, or are you going to be writing code that's supporting the newest versions? Document that so you don't have to have the same argument every time you're writing a new feature. Beyond documentation, then it's time to actually start refactoring your code. So you put on your refactoring hat, which means you are not writing new features. You're not changing the functionality. You're just refactoring it. You're just changing how it works, changing the underlying code of how it works without changing the overall functionality. So look at the diagrams that you wrote earlier. Figure out which parts of it don't make sense, which parts of it are likely to change, which parts of it need to be further encapsulated, which parts of it which parts does the strategy change when your users set different options. Start encapsulating all of those pieces, test those pieces as you're encapsulating them, and just keep iterating over that over and over. Keep making small changes. Test those small changes as you're going. Your test base is going to grow. You'll get more and more code coverage as you go, so that you can start making bigger changes and feel confident that you can make those without breaking everything. Just make sure that you're learning to do all of your refactoring the right way. Read this book, please, read this book. Refactoring by Martin Fowler. It basically catalogs every possible kind of refactoring that you're going to be doing and gives you safe steps to follow to do so without breaking your code. So that's basically the outline. My name is Jonathan Brinley. My company is Flightless. I do a lot of work with Modern Tribe. If you want to write good code and make old code better, please come work with me at Modern Tribe. And yeah, there's my contact information. Any questions? Yes.
Can we test like multiple plugins with that, like being able to install a plugin?
Yes, yes you can. Basically with Codeception, you can set up multiple configuration files. So I'll often set up one to test the plugin by itself, and another configuration file will tell it to load my plugin plus this other plugin. Or if I have 3 plugins that work together, I'll tell it to load all 3 together and make sure that they're working together correctly.
Okay.
Yes?
Could you back up one slide? I just wanted to see the title of that book again. Thank you.
Yeah. Refactoring is straightforward. This is basically the Bible of safe refactoring.
How do you justify the work to your client? And I mean, you can't totally hide it under the covers.
Right, yeah, and there's 2 approaches there. There's the covert approach, where you just pad all of your estimates to say that you're going to, or so you're saying to yourself that I'm going to spend a little bit of time doing this. And overall, if you're following the Snowball approach, you're starting small, and you're just making these little bit of changes here and there. It doesn't really add up to a lot, so you can do it fairly covertly. The overt approach is definitely requires a little bit of sales on your part to your customers. If you have good project managers, they'll often be understanding about things. But if you have customers that are smaller customers, they don't want to pay for a rewrite, then you have to be upfront with yourself that you've made mistakes in the past. You probably shouldn't have estimated things as cheaply in the past as you have. You might need to suck it up a little bit and do some of your work yourself. But at the same time, tell your client that you're working on making it better so that they can get more features faster, cheaper in the future. And so by investing this time and this money now, that you're going to see payoffs in the future instead of ending up with a product that you're going to have to throw away.
If I can address that point
Yeah,
as well, in my experience, the how in which we develop software is entirely our responsibility as developers. What we develop for the client is what they care about, and the time is a certain portion of it. But no one dictates to us whether or not we must use source control, or whether or not we should use Bootstrap, or someone else's separate components, or a starter theme, or a plugin framework, or any of that stuff. So to a certain extent, it is transparent to the client, as long as you price yourself accordingly, that this is a part of the process that you're going to adopt. This is part of what makes quality software and what makes you confident when you deliver quality software. The client's never going to ask you, nor are they ever going to care. So did you write tests for them? The client will never ask you, nor will they ever care if you wrote tests of a piece of software or that you used an automated testing tool.
Speaking of the test harnesses or the test tools, can you just switch them off to production, or do you have to, you lose the integrity of the code if you have to pull it out?
Yeah, so let me exit out of here and show you what I have in a couple parts. This is for Modern Tribe's event calendar. So we just have a directory in here called tests. And when we package this up for distribution, we just have a grunt task that runs, deletes that directory, and a couple other things that don't really need to be going out in the public code. So if you go to our GitHub repository, you can still see all of the tests, but if you're downloading it from the WordPress plugin repository, you have a lighter weight package to download, because you don't need all of the tests there to run the plugin. You just need them there if you're going to be doing development, testing the plugin. I also do that if you're working not on a plugin, but on a whole site. Yeah, so I'll often put in like a dev directory, and then when you deploy that, whatever deployment tool you're using, you either just exclude that folder, or I often just set it up so that it's outside of the web root, so it may be on the server, but files will never be served.
Thank you.
Thank you all for coming. Thank you very much to the organizers and volunteers.